All right, the topic that we're talking about today is graphing polynomials. But I feel like before we can even talk about graphing them, we really need to be able to identify whether something is a polynomial or not. Okay? So we're going to go through these 5 functions in just a moment. I'm going to give you a chance to get them copied down. But we're going to go through each of these 5 functions, and as we go through the functions, you're going to be able to tell me whether it is a polynomial function or not, and why. Can anybody tell me about f of x? Is f of x a polynomial function or not? Yes, why do you think it's a polynomial function? Because you already read the definition in the book of a polynomial function and you saw that all the exponents are whole numbers and all of the coefficients are real numbers? Oh, yes, excellent. Oh, okay, good, good. So f of x is a polynomial function or is not a polynomial function? It is, correct. Okay, what about g of x? Okay, so for the record, one of those is correct. It's either yes or no. The exponents are all whole numbers and the coefficients are all real numbers. Why is it not? Do you guys remember this that we made at the beginning of the year? Everything on this page is a real number, right? Why did you think it wasn't to begin with? Tell me that. Oh, 0.8. Okay. So, and the square root of 2. Okay, but are those both real numbers? Okay, so we're okay with it then? All right. So what?
So the coefficient would have to be a real number.
Yeah. Okay, what about h of x? Ooh, it has a negative 1. But isn't 1 a whole number? 1 is a whole number. What makes something a whole number? If it's 0 or above. But like a counting number, right? Negatives are integers. Negatives are not whole numbers. Very good. So f we decided was yes. G we decided was yes. H we decided was no. Why is J also no? How do you know that? You don't. That's the thing. By definition, a variable is something you don't know, right? So you have to assume, well, assume is the wrong word. You can't, in fact, assume that x is a whole number or not. So we just say no, it's not a polynomial function because we don't know for a fact that all the exponents are whole numbers. You were right. You know I'm going to argue with you sometimes, though. Okay, what about k? No, why? Half is not a whole number, is it? I mean, it seems logical that half would not be a whole number, but that's just a silly math joke. Okay? Any questions about any of those? So f was yes, g was yes, h was no, j was, and k was no. Okay? Any questions about that? All right. So like I said a minute ago, the topic that we're going to talk about today is end behavior. Graphing polynomials. You know and I know that we could just turn our calculator on, plug in the equation, hit graph, and that would be it, right? Guys, that's not the skill we're working on today. We're not working on the skill of button pushing. Okay? We're working on the skill of knowing what the graph looks like before we punch some buttons. Okay? But before we can start, talking about that, there's some words that I need to make sure you understand the definitions. In some classes, they call these vocabulary. For the record, that does not say leading coefficient, that's leading coefficient. What is a leading coefficient? It's the first one, right? It's the first coefficient when what's true. That's close. I don't know what that spells. It's supposed to say form. Form. It's the first coefficient when the polynomial is in standard form. Now, what do I mean by standard form? So ax squared plus bx plus c is standard form of a quadratic, and I'm glad you know that, okay? But it's all polynomials, not just quadratics. So what would make any polynomial be in standard form? If the biggest exponent's first, and then the next biggest, and the next biggest, and the next biggest, right? Or next smallest, I guess I should say. So if the exponents are in decreasing order, then it's in standard form. Are you okay with that? Okay. Another vocabulary word I need you to know is degree. There's quite a few definitions of the word degree, even in math, okay? But the degree that we're talking about in this particular situation when we're talking about polynomials is the highest exponent. It's not difficult at all. You look for the biggest one, that's the degree. Okay? Any questions about that? All right. So I can use those two vocabularies. I can use those two words and you guys know what I'm talking about? Okay. So let's talk about the end behavior. If I'm talking about a graph, what do you think I'm talking about when I say end behavior? So as it's going all the way to the left and all the way to the right, what's happening those directions? Well, it's not going to end. You're correct. Okay, polynomials are not going to end. They're continuous and they continue to infinity, right? But because of what we know about polynomials, we know it's not going to suddenly just change direction. Once it gets to what direction it's going, it stays that direction for infinity, doesn't it? We have to figure out what that end behavior is. Now, fortunately, there's some pretty cool rules about end behavior. Okay, pretty simple to remember rules. And honestly, the way I remember them is by remembering two things. Okay? I remember what the parent function of a parabola looks like. And I remember what the parent function of a cubic looks like. And from these two, I can remember all of it. Okay? Now I'm going to write some rules down for you so you have them, but just know that when I'm thinking of end behavior, I'm thinking of these two graphs. They take care of everything for me. Okay? First of all, let's talk about this first one. Okay? Y equals x squared. What is its left end behavior? As it's going to the left, what's happening to it? It's increasing. It is rising. Rising is the word we typically use when we're talking about end behavior. Rising and falling. Okay? So as it's going to the left, it's going to keep on rising. It's going to keep on increasing. Okay? What's happening to its end behavior to the right? Also rising. Okay? What would happen if this was actually y equals negative x squared? It would be falling, right? That's a reflection of the x-axis, so it would be here, and both of them would be falling, wouldn't they? So the first thing that I remember is that their end behaviors are the same. They either both rise or they both fall. Okay? Now, if the leading coefficient, are you okay with me writing LC and that meaning leading coefficient? If the leading coefficient is positive, what's happening to both of them? They're rising. Okay? And we're going to say it rises left and rises right. What happens when the leading coefficient is negative? Falls left and falls right. Now, do you see why I keep this in my head? But something is really cool about this, okay? Because I can remember all of the end behaviors of all of the functions based on just these two. Because I also know the rule is this is the same kind of end behavior as long as the exponent is even. The degree is even. Okay?
So every degree that's even is going to be like that?
Yep. If the degree is even, these are all the same rules. Isn't that cool? So what do you notice about the end behaviors right here? So then they are opposite. Okay? So end behaviors are opposite. Well, what's really cool about this, though, is all of these work when the degrees are odd. And look, odd degrees are opposite. It's like some alliteration. So, what is happening when the leading coefficient is positive? What's happening here? So, falls left, and it rises right. Now, for the record, I'm always going to tell you what happens from the left first and then the right, because my brain is ingrained to talk about domain, and we always talk about left to right first, don't we? When we talk about domain, we talk about least to greatest, lowest to highest. So when I talk about end behaviors, I always talk about left first and then right. It's not wrong to talk the other way. I'm just letting you know I'm always going to say left to right. Okay? Plus, it kind of gets you in the habit of talking about left to right when you're talking about domains, so it's probably a good idea. Okay? What about when the leading coefficient is negative? Rises left, falls right. Is that hard? None of it, is it? Okay? So what I'm telling you then is you're going to be able to know what the graph looks like for the most part before you even plug it into the calculator. Because you know what's happening in the end. Now let's talk about what's happening in the middle. Okay? Well, what's happening in the middle is really based upon the degree. Okay? For example, if I have f of x equals x squared plus 5x plus 6, tell me what the degree is. 2, right? Now, what shape is this, by the way? It's a quadratic, so it's a parabola, right? So, looking back here, I know that it looks something like this, right? Now, this is pretty much the parent function, so it's not exactly here, but it's somewhere. And it's shaped like that, isn't it? Well, how many times has this changed direction? Just one time, right? It has one change of direction. So we also call those turns. How many turns does it have? It has one. call that g of x. Let's say g of x is x cubed plus 2x to the squared, 2x squared plus 4x minus 6. What's its degree? Well, so it'll look like this, right? How many times does this change direction? Once here and once here, right? So it changes direction twice, so it has 2 turns. Well, what about a line? You know what a line looks like, right? What is its degree? 1. How many times does it change direction? None, so it has 0 turns. So what I want you to tell me then is, what if my equation is this? What's that? What if that's my equation? What is my degree? 5. How many turns do I have? Without even looking at it, you can tell that there's 4 turns. How? It's 1 less than the degree. Most of the time. Most of the time. Okay? Most of the time it's going to be 1 less than the degree. This is something I have to draw for you, if that's okay, so I can explain what I mean. Okay? Here's what I mean. If we have, I'm just going to draw it right down here. Okay? Let's pretend we're talking about this one right here. Okay? Tell me about its end behaviors. Well, it's a 5, so my degree is odd, so it's going to have opposite end behaviors. And my leading coefficient is positive, so it's going to fall left and rise right, right? So it's going to fall to the left and rise to the right. Is that correct?
Yes.
Okay. I'm telling you, or we're guessing that there's 4 turns. 1, 2, 3, 4. Does that make sense? But couldn't there also just be 2? Doesn't that fall left and rise to the right? Could there be 3? 1, 2, 3. To fall left and rise right? No, right? Because I would have to get back up there, and that would add another turn. We can't have that. So there's either 4 turns or 2 turns. So how are we gonna say how many turns there are? If the degree is 5, how many turns are there? 4 at the most. Does that make sense? If there's less, how many are there going to be? Less by 2. Okay? So what if, what are we on, k? Yeah, k of x. What if it said negative 6x to the 9th plus 4x to the 3rd plus 2x minus 6? What is its degree? 9. How many turns are there? Or 6, or 4, or 2. You understand? Does that make sense to you? Good. So, I'm sorry, go ahead. Officially, no, it doesn't matter. I just always start with the biggest and go down from there, so I make sure I don't forget anything. Is it possible, here's the one we didn't talk about though, is it possible that this is 0? That would be a line, and we know that this is not a line, don't we? Okay. All right, so let me show you what I'm expecting on your homework for tonight. Can I do that? Let me show you what I'm expecting on your homework tonight. This is actually what I want to see. Okay? So for example, f of x equals x to the 5th minus 3x to the fourth plus 2x minus 4. Like, the only difference between what I'm showing you and your homework tonight is your handwriting. This is how I want it set up. Does everybody understand? I want the degree. In this particular problem, what's the degree? 5. I want the number of turns. 4 at the most, and possibly 2 instead. Okay? And then I want the end behaviors. What are the end behaviors? Okay, it's an odd function, and it's positive, so it's going to rise to the right, so it's going to fall to the left. Fall left, rises right. And now I want the graph. I don't want the official graph, because that's practicing your button pushing skills. I want this. Falls left, rises right. Maximum of turns is 4. 1, 2, 3, 4. 1, 2, 3, 4. Done. You don't have to show both of them. You can just show one. That's fine. Okay? The maximum number of turns would probably be the best idea, yes. Any questions? No questions? If you do have questions as you get started, you come back here and we'll talk. Or I'll come up there and we'll talk.